let me move on to the main event of this afternoon, which is to meet Mr. Simpson here, Andy Simpson. I'm not going to give you the big bio. I'll let you do that for yourself. So, Andy, why don't you tell us a little bit about yourself and where you're from and what you're going to talk about today?
Okay, thanks very much. Well, first of all, I'm going to start with thanking you all for making the effort to come. I hope it wasn't just for the lunch. I hope you'll learn a little bit about what we're talking about today. My background, I've been in manufacturing for over 35 years. I've set up Angus 3D Solutions in 2017 because I see an opportunity there of using additive manufacturing in not just the oil and gas industry, but a lot of industries that are around this area. So I'm hoping that you'll go away with a little bit of understanding of the technology.
Okay, that's grand. Why do you think this subject is so important then? What impact do you think it could have for us all?
The technology regarding relating to the oil and gas, I think it's got a lot of potential. I don't think the oil and gas industry is using it to its full potential yet, and there's great opportunities there. So I think it's a great opportunity to come and speak today and hopefully shed a little bit more light on that.
Okay, super. We're looking forward to hearing what you have to say, but before we do that, I want to bring in OGTC's resident additive manufacturing expert, Mr. Andy Bell.
Good afternoon.
Andy, why is this subject so important to us here in OGTC?
So it's one of those emerging technologies that the Oil and Gas Technology Centre are really quite interested in. As Andy mentioned, other sectors such as medical and aerospace are that much further forward. They've more widely adopted it. So we want to look at how do the OGTC implement this technology? How can we save costs, reduce stock? Can we print on location? These types of things. So hence why Andy's here today.
Super, thanks, Andy. So without much further ado, be prepared. Your 20 minutes are just about to start. Before we start off, I just have to say we're going to finish off at 1:30, no matter what happens. So I will huckle everyone out the door. So you've got 20 minutes or 19 minutes and 56 seconds, starting from now.
Okay, thanks very much. I'll start off with 20 minutes. This is a big challenge for me because usually I can talk for about an hour and a half on this subject. So please, I'm glad there's a stopwatch timing me here, okay? So let's move on. What is additive manufacturing? I'm hoping that most of you have probably been exposed to it through the media or know a little bit about it. But just very, very quickly, this is what the media wants you to totally believe, okay? You design something, you create an STL file, we chop it up into layers, we 3D print it, bingo, job done. It's a little bit more complicated than that, okay? There's a lot more work goes on in the background to get to this, okay? Management materials, etc. That's not any different than what we're doing today with when we buy a piece of bar stock, we've got to control it, we want to manage traceability, etc. So it's important to understand that this is simplified, but there's a lot more going there in the back of it. So we do design stuff, we do cut it up layer by layer, and then we grow it one layer at a time. Okay? The advantages of doing that over traditional manufacturing or subtractive manufacturing is when you print something or grow something layer by layer, the complexity of it disappears. It doesn't see how complex the part is. Traditional manufacturing, the old school, the first thing a traditional manufacturing guy looks at is when they look at a drawing, the first thing they do is what's going to cause us problems. Okay? They'll instantly look for the negative in manufacturing. With additive manufacturing, we actually remove that. So it's a completely different way of thinking about our manufacturing process, which then has an effect on the supply chain, how it fits into the supply chain, which we're focusing on today. So, a couple of questions here. Is additive manufacturing the technology to be used for all our future manufacturing needs? No, it's not. It doesn't tick all the boxes all the time. It never will. It'll tick more and more boxes as we go along as technology develops, but it won't. It's not any different than CNC machines. When they first came out in the late 1940s, 50s, everybody thought that's it, they'll do everything. They don't. It's not any different than injection moulding. It doesn't do everything. So it'll have its place. But it won't be the answer to all our manufacturing dreams. Okay? It'll be another tool to be used excuse me, in manufacturing. And how does it fit along the traditional manufacturing? The traditional, when I say traditional, I'm talking about particularly in subtractive manufacturing, your milling, your turning, etc. It will sit next with it. The machine shop, the manufacturing shop of the future will have lathes, milling machines, machining centres, additive manufacturing. It will be another piece of the equipment. Will work hand in hand. So again, if we think additive manufacturing is going to, we can buy one machine that will do everything, it's not going to happen. I mean, additive manufacturing, I'm saying it really negative, isn't it? It's not. I'm just making it very clear. It's got its place like every other manufacturing method. What is happening is it's working hand in hand is that we will now be able to get machine tools where it has additive manufacturing and traditional manufacturing all in one. That will allow us to then do a lot of the growing first of the material that we need, and then we do some of the finishing for seal faces, etc., through the traditional methods. I touch on direct and indirect, right? Now, this is something that I've been talking about quite a while. I'm going to focus a little bit on indirect first. Indirect is what a lot of us think 3D printing falls into. Prototypes. Oh, it's only for prototypes. Okay? We don't use it for anything else. So it's a means to an end. Print something off. Yeah, it looks like what we're wanting to make. So yeah, we'll put it into traditional manufacturing. And it will also have that place of prototyping, but it does more than that. It does direct, meaning it goes straight into the end product. A lot of industries are doing that. I think now if you go into a boat, a kind of A350 aeroplane, there's more than 1,000 parts that have been 3D printed. Okay, finished product. Indirect as well, just to touch on. A lot of it we're using now is where we do a lot of reverse engineering, or we do a lot of aftermarket work. So what we're doing is we're actually taking the part, maybe 3D scan it, create a digital file, create a 3D printed part. Then what we do is we actually send it to a foundry and use that as a pattern. So we go back to our traditional manufacturing. Some parts, in fact one part I made recently, it was originally made in 1912, and today the best method of manufacturing was still the method in 1912. We couldn't beat it. But what we did do was we used additive manufacturing to help us get there. We helped by getting the part, scanning it, and creating a digital version of it, then printing that off and using that as our pattern to help us. I see that approach a great benefit, particularly in the oil and gas industry, for used equipment, older type of equipment. The direct, that should be, in the oil and gas industry, we really need to start looking at that. Is it the new product that's coming out, the new technology that we're developing, that we're starting to look at it, design it with this in mind, because the design requirements for additive manufacturing and traditional manufacturing are completely different. So in the oil and gas industry, I think there's a place for both. There's indirect, reverse engineering, aftermarket type equipment, a new product in the direct manufacture. I touched on that aftermarket. We're doing this, I'm doing this, to be honest with you, when I set my business up, it's not something I thought I'd be doing an awful lot of, but it's turned out I am, because there's a demand there, where we're finding that there's old pumps that we, and particularly in this industry, is we go, let's go and get a spare. Okay, it's obsolete. It's not obsolete because it's old, it's just that we can't find it, find the drawings. because a company's been bought over by a company who's been bought over a company, and that data disappears over time. So being able to reverse engineer it, create that digital file, do a 3D print, and use these prints as the actual pattern for recasting stuff. So here's a perfect example here at the bottom here, which was a gear cover, reverse engineer it, create a pattern, and then we cast a complete new one in aluminium. Can we mass produce is a question that we're often asked about. The answer is, what's mass production? Okay, you know, one industry, mass production is millions. Another company or another industry, they were talking about hundreds. I can guarantee you today, additive manufacturing will start getting, they're developing machines. This is a machine here which is called Future 4. And the idea being is that it's the take-on injection moulding. Produce parts as quick as injection moulding. One of the biggest advantages of this is, instead of it taking 12 weeks to get the dies, etc., manufactured for injection moulding, basically it's loading a digital file to the machine, job done. Okay? So there's a lot of benefits for that. So when you're doing a larger batch of quantity, yes, if it's injection, you know, millions, injection moulding is the place to go. But in the oil and gas industry, you know, from my experience, mass production is anything over 5, you know. There's a lot of things, very rarely there's, you know, big orders where there's hundreds and hundreds, unless it's widgets, okay? But in the more technical stuff, it tends to be the lower numbers. So when people dismiss it for mass production, we're getting to a point, we're very much getting to a point when it comes to supply chain, we really need to have to think of that. Producing in this technology, the lead time from the moment the order is placed to the delivery is a lot less. I'm finding just now where I do supply traditional manufacturing parts, okay, for every week that you get quoted on traditional manufacturing is equivalent to around about 1 day in additive manufacturing. So if you get quoted for a metal part, 12 weeks lead time, you're probably talking about 12 days in additive manufacturing. Okay. Okay. Will this technology solve all today's problem? I'm going to really be bold here. I'm going to stick my neck. I'm going to say yeah. All right? I've just said earlier on it doesn't tick all the boxes. The problems we've got today will be solved with this technology. The reason I say that is because this technology, yes, it was sort of first developed and invented in the 1980s, but in the past 10 years, especially when it comes to metal printing, has developed so much, and it's got a long way to go. Go back to a CNC machine, started as an NC machine in the late 40s, early 50s, with 2 axes, okay? Now, 9 axes is probably the maximum they're doing. Most machines are around about the 4 or 5 axes. This technology has still got that opportunity yet. You will see machines, additive manufacturing with 9 axes on them. You will see additive manufacturing learning off the CNC background and developing. So it's still got the years to come of development. That's where traditional manufacturing is probably getting very close to being maxed out. There's very little you can add to it, to the point that these companies now are actually adding additive manufacturing into their machines. Okay? So, it's a bit of a bold statement saying, yeah, it's going to sort all today's problems, but it will. The problems we've got today. It's not to say tomorrow we've got new problems that it can't solve, okay? But most of the manufacturing problems we see today are challenges. This technology would do it through new designs, etc. I scrubbed out the supply demand, this supply chain, right? I'm sure we've all been in facilities and warehouses. It's full of stuff, all right? Full of equipment. Okay, so we manage our businesses around our supply chain, all right, not the other way around, right? Anybody argues that, saying, well, how much inventory have you got? Okay, that's how much money you've got tied up because your supply chain, you're managing your supply chain because that supplier says to you, I need 12 weeks to supply you this. And you're sitting there going, oh, I need this in a week. So I now got to hold inventory so that when I'm ever faced with these future challenges, I can deliver to my customer within that 1 week. So you build warehouses, okay? So what I'm saying here is demand. Change it to the demand chain, not the supply chain. So we're actually building that to the demand. If I need something this week, I then start it and manufacture it this week. I don't have warehouses to do that. So, but we've got to change that mentality. So it changes it, lower risk and contingency. If you're using additive manufacturing, and I'm not saying necessarily use everything in additive manufacturing, but a lot of companies are actually traditional manufacturing and additive manufacturing, hand in hand. They have their group of suppliers producing stuff, and they're using additive manufacturing for that rush order to get them off the starting blocks while the old-fashioned supply chain comes in. So again, if you're in mass production and you're looking for millions, it takes a few weeks to get this traditional supply chain kicked off. So you kick off the additive manufacturing, start producing on there, and then when this comes online, you can back out of it. That helps a lot with cost. They're doing the reaction very quickly. It might cost it a premium, but then you're still getting the benefits of the mass-produced product from elsewhere. It helps you iterate and innovate better, okay? That's what it's all about as well, okay? The beauty is being able to change very quickly. One of the big problems that I've seen or face is, and certainly companies I've worked for, is, no, we can't change that design. Well, why not? Because look at the amount of inventory of parts that we've got in the store. We need to run that off, okay? So what we're saying is we've got a new idea, a new technology to improve it. We can't implement it for another 3 years until we'll run off the inventory that we've got already. That disappears with it. If an engineer wakes up in the morning, designs something better, he can implement it very, very quickly in there the next day. He doesn't have to worry about that. No, he doesn't worry about it anyway. The accountants don't have to worry about it. Reduced material use, and this goes slightly with the circular economy as well. Over 77% of traditional manufacturing material goes into a skip. Okay? And additive manufacturing is around about 7%. When I say, 77% UK, right? Survey done, 77% of UK manufacturers material goes in it. In Scotland, that goes up to 83%. Okay, we're actually worse at it in Scotland. Okay, so there's benefits there. Accelerate time. Consolidation. Instead of making 10 parts, okay, or GE with their LEAP engine, instead of having 20 parts and a fuel nozzle, you've got one part. One part. They don't have any assemblies. They don't have to keep inventory of 20 parts. They don't have any of that, and they're actually getting 5 times the life cycle of it because they've just designed it for one part. Reducing tooling costs, another great benefit of it is because you don't have that tool cost, you can get straight onto manufacturing straight away. You don't have that pre-manufacturing steps either by making tooling, etc. You can put your manufacturing anywhere you want. All right? These centres of excellence that we tend to build in the oil and gas industry, okay? Well, there's still a place for them. However, if we can start moving it, localising the manufacturing process, we can get it closer to our customer. Some industries, they actually put that next door to their customer. They're hundreds of miles away, but they build a little unit right next door to their customer and feed it in straight to their customer. Simplifies the process. When I say the process, I'm not just talking about the manufacturing, but also the demand chain. It's driven, demand driven. It's not about supply driven. Right? One customer I've got, he now he buys a lot of copper off the market to wind onto electrical bobbins for forklift truck brakes. He now buys the material that he can get at the best price, the copper, brings that in, then he designs the bobbins to fit the copper, and he saves hundreds of thousands a year by managing supply chain differently in that way. And reduce costs. Time is where I told you I could speak an hour and a half on this. So, my ask, how can the oil and gas industry influence technology? The biggest thing that I get asked is, and I'll ask before anybody asks me in the next 20 minutes, quality. Okay? The oil and gas industry is the biggest critic when it comes to quality, when it comes to additive manufacturing. However, they are the industry that use it the least, but the biggest experts on the quality. How does that work? Okay? Aerospace, automotive, medical, etc. Okay? 1,000 parts in an airplane. Okay, some of you might not decide not to fly now, but it just doesn't happen. It didn't happen. They didn't just print one part off and decide they're going to stick it in an airplane, job done. It took years of development, building confidence. Not any different than any other process. You've got to build the confidence. The whole thing is, the more you put in, the more you will get out of it. So as the industry, I would say to you guys is, what are you going to put into this? You know, you need to contribute through these type of things, engaging with the centre, asking them what, or telling them what you actually need from the technology, and they will bring the right people in and explain what you need, explain more about the industry, and all of a sudden now, this technology will come oil and gas driven, not aerospace or automotive driven. There'll be something there for the oil and gas industry. If we don't do that, it will always be seen as an aerospace technology. Okay? Bang on 20 minutes. Thank you very much.
Just trying to come and go.
Thank you very much.
Thank you very much, Andy. That was very, very interesting, and I learned quite a bit about additive manufacturing that I didn't know before, so appreciate that. Now we have 20 minutes question and answer session. So is there anyone with a burning question that they would like to pose to Andy to get our session kicked off?
Thank you. Angelis from GR&D. My question is, I've known a lot about manufacturing, and I've been using manufacturing for a long time. And 3D printing has been, for me, the motive in improving design and being able to do things that no machine shop can ever make for you, you know? So it's definitely very important to consider for innovation and oil and gas. But what I do found is there is a lot of limitations. For example, there's limitations. One thing you didn't touch today is materials.
Yeah.
So people ask, can you make metals? And then they say, can I have a certificate for this material that meets the standard XY? So is this something that you can see being developed in the near future for the metals like downhole environment and API and NACE materials and all this?
Good question, yeah. I mean, it is probably one of the big questions that always gets asked. And there is as I say, it doesn't tick all the boxes. Materials is one of the bigger challenges. Material and size, okay? So there is a lot going on with the materials. But like anything else, just as I said there, what do you put in? The other industries have managed to get through that, and that's by engaging with companies and saying, this is what we need, and this is what it needs to meet, okay? And then once that's done, the companies start working on it and saying, right, okay, there is a market for this type of material, to this type of grade, to meet this, etc. On the traceability and the traditional managing material, that's coming along, okay? You've got the people like Lloyd's and that starting to put in the specs, etc., so that people outside the aerospace industry, they can relate to it. Because let's face it, if you and I picked up a spec for the aerospace, we'd be going, what are they talking about? What language are they talking about? Okay? So they're now translating it to the oil and gas. so that it's more relevant to, because there's materials out there, you know, that we could use. It's just that they're not presented in the way that we're used to. It is coming.
So do you see the oil and gas industry to make a big contribution in order for you to grow and be able to develop further? I'm very familiar with the development in 3D printing and metals because I'm very eager to get it available for what we are doing. So it is very, urgent. I would say that the fact that, all the business are going off because of this reason, that you don't tick all the boxes, like you said. So
yeah. Coming from the oil, I've sat on both sides of the fence, okay, being a supplier or being a person that's banging the desk and saying, I gave the order yesterday, so why is it not here today? Okay? And when it comes to this technology, it's very much that we're really impatient in the oil and gas industry. All right? The amount of companies I go into where they'll turn around and say, right, okay, can I do this, this, and this? And I go, no, not. I'll come back and tell me when it does. All right? Okay, and that's where we are. So that we need to change, okay, is putting something in to get something back, okay? I honestly, genuinely believe that we're very close there. We need one or two, and I'm working with one or two companies that are dipping their toe in it. But again, it's like any new technology, it's like anything, it's like bringing on a new supplier. You don't give them the A1 job straight away. You build that confidence up. And that's what I think is needed with this technology. There's still got to be some restraints with size, etc. But again, the size restriction is driven by what other industries need. If we turn around as an industry and say, this is what we're looking for, I can guarantee you somebody's going to build that equipment.
Thank you.
Thanks very much. I think we've got a question right at the back.
Right at the back there.
Television's Mr. Roger Essen.
Good afternoon.
Good afternoon.
Roger Essen from the Decommissioning Solutions Centre and also working on the Decommissioning Centre of Excellence. We've got a question though, picking up on that very point. If you could get a component or a bit of kit offshore tomorrow that would start to build the confidence in this, what would it be and how can we help?
Oh my goodness. Oh, talk about throwing one there. Right, next question. It has to be something that gets attention. Okay, again, something that goes offshore with a bit of attention comes with high risk. All right, it's definitely one of that. Me personally, my company, I would say no. Let's build that. I spend a huge amount of my time or focus just now is building that confidence in the technology. It's not about selling this company, it's about selling the technology, building that up. So you can see the politician in me here is coming around avoiding the answer here, but that's where I don't know the answer to that.
How about a gas turbine blade or something like that? If it's accepted in the aviation.
Yeah, I mean, okay, that's great. Gas turbine blade, absolutely, no problem at all with that. It's in a previous life, I've been exposed to, aftermarket and refurbishing of gas turbine blades, and there's no reason whatsoever that this is the technology that takes over from that. I mean, definitely. Thanks for the prompt there. Thanks for bailing us out.
Hi, I'm Steve Johnson from Cavitas Energy. Now, this is probably quite a specific question.
Okay.
So you've touched on, when you were answering that gentleman's question, size constraints. Mm-hmm. So the company, my business partners and I are developing a fairly disruptive, we think, bit of downhole technology. And all of our prototypes to date have been made by sort of traditional manufacturing. But we're aware of 3D and are looking at it. Mm-hmm. So if I needed a single rotating piece of equipment that was geometrically shaped in metal, 3 meters long, is there technology there that can do it?
No,
in 3D printing?
Not in one go.
Okay. No,
not in one go. I think the biggest metal 3D printer is about 800 millimetre. Okay? Yeah. Traditionally it's round about the 250, 350 high.
Okay.
There's a machine going to be commonly used in the UK here later on this year, which is 500 cubed. There is companies that are doing 800, as a maximum length it's doing. Everything else has to be joined. All right?
All right.
So that's it. Again, it's not ticking that box yet.
No, I mean, it's not necessarily a complete killer for us. I mean, we have considered manufacturing it in smaller pieces and joining it together, but obviously everywhere you've got a join is a potential
So,
failure point.
here's, just to put that question back to you, have you designed it with additive manufacture in mind?
No, probably not.
Right. Design it with additive manufacture in mind and have a look to see how short that becomes.
Okay.
Because at the end of the day, is the great thing about additive manufacturing, here's one rule. I go into companies and I say, you want to make it as light as possible. We're not interested, we don't need that. I'm going, you're wrong. You do. When you design something, always think in the back of your mind, always have it, how do I make this component as light as possible? Design it with it. So forget the traditional rule book of manufacturing design. Okay? Throw it away. Design it. This is where great, naive, out of university design engineers are great for this technology because they haven't learnt that rule book yet. Just design what you want it to do. But always, the aim is remove as much material as you possibly can. It's not just about weight. The more material you remove, the lighter it is, the smaller it is. I've seen parts where they've taken like a heat exchanger, this kind of massive thing, and they've turned it down just a small component by just changing the design aspect of it. So my challenge would be is go back, throw out the rule book, design it from additive manufacturing. So what you actually want it to do from A to B, that's it. Nothing else, not an ounce extra of material in it, and it's a different design than what you're talking about just now.
All right, thanks very much.
So, just touching on a gentleman's topic about the 3 metre length, the likes of wire arc additive manufacturing, could that not achieve those types of lengths?
Yes, the answer would be. Yeah, you could do it that way, yeah.
But is there less,
yeah.
is there
but
less
there's less control,
in that?
less tolerance held, and you've still got a huge amount of additional traditional manufacturing. So there is that way up, is that you're very much, again, you know, it's a great question to ask. It's like a balance. You know, you could make something longer, use a different technology, but then you increase the traditional manufacturing content as well. Okay, so you still need that. If you want to remove a lot of the traditional stuff, then you've got to change the design a lot more. And that's one of the things I get a lot of folk going, God, it's really expensive. I'm going, yeah, because you're actually giving me a part that's been designed for traditional manufacturing, you know, a flange, solid thing, and you're wondering why it costs 10 times more than what you are getting out from a local supplier, because it's not been designed for that.
Hi, so I'm Rebecca from the Asset Integrity Solutions Centre. One of the things we see as maybe a barrier is the original manufacturer, no? And are they going to be acceptable to having third-party parts? Because then where does the liability sit? And is that something that we need to consider before it comes into commonplace?
Yeah, I mean, that is a huge risk and will cause problems. And I'm working with a couple of companies where they have, again, they're looking how they can save cost. So traditionally, when something went wrong with this piece of equipment, it was basically, let's throw it in the skip and buy a new one, because they had the luxury of doing that. Today, that ain't going to be happening. So what they are now doing is stripping that equipment down, going, hold on a minute, is that all that's wrong with it? And when they go to the OEM goes, nah, you have to go buy the whole thing. You know, we don't want to supply the parts. You know, or some of them who do, they're just as cheap buying the whole part for the spares and the lead time. So what they have done is they've actually sat down and said, right, we can't live with that. What are we going to do? So they've actually started now reverse engineering and changing the design so that the design is more suited for additive manufacturing, and certainly to try and get more, you know, a larger life cycle out of the part. Now, they're putting that back in, okay? That's at their risk, obviously, because there's not going to be any warranties coming with that. But they're doing that risk assessments there and saying, right, how much risk is that to our business by doing that reverse engineering, doing these product enhancements, etc., and changing the design and putting that in there. So there's not a straight answer. I'm full of non-straight answers, right? Is depending on the company, the product, etc., and particularly the risk involved.
And that's where we bring a lot of new technology to the market.
Yeah.
And give that opportunity, but a lot of some of the adoption pieces around that human factors, the human behaviours and that appetite for risk. So that's something that we as a technology centre are aware of and are looking to the industry to say how do we overcome those.
Yeah, and it's not just additive manufacturing, it's anything that we do in the industry is, you know, regardless if somebody has got designed a Parker, okay, and they get all that approved, etc., you know, and it's all signed off, it meets this, that, and the next thing, requirements, and then it goes to the customer and they're happy with it. You come along and say, I've got this part, it's great, this will make the part here last for an extra X amount. You know, the industry turns around and goes, we're not interested, all right? And it's not because they don't want to, it's because they've got to go way back and start jumping through all the hoops again to get to basically back to where they are. And sometimes that is the off-putting part of it. So you come along with this technology and say, oh, hey, we can make it a lot better and cheaper and things like that. They're going, hold on a minute, I've got to jump through 20 hoops to get basically what we've already got today. Nah, I'll not bother. Yeah. So it is a challenge. Okay, well, at that juncture, I think we'll call the proceedings to a close. I'd just like to say thank you very much again, Andy. If everyone can show appreciation, that'd be super. Thanks very much.